Hi, Assalamualaikum warahmatullahi wabarakatuh. I want to talk about a project which is a predicting a cryptocurrency, which is a closing price, and using historical data. So basically, we evaluate the model accuracy and the ability to prediction, which is up or down of a price movement. Thank you. So our project methodology is the first one. We use a data processing. So we learn historical, historical cryptocurrency data, which is open, high, low volume, and close. So second one is a labeling. We label data, which is a silent numerical feature. So derive a binary up or down label. So a third one, we model implementation. We use a true model machine learning, which is a linear regression and decision tree. So we can make a comparison, which is a better. And the fourth one is we training and then testing the data. So we split the data into a training about 80% and the testing 20%. So we can fit the model and we predict the model in the data. So last one, evaluation and visualization. So evaluation, we use a true evaluation model, which is a MSE for the error, and then the R2. And basically, MSE error is a less error is a better one, and then R2 is a closer to one is a better one. So and then the plot actual vs predicted, and then the confusion matrix to comparison, which is a better. Thank you. So for the model selection, we compare both of accuracy and direction prediction. So we to comparison. First, linear regression is simple and interpretable. It's a model for regression. And then for the decision tree, it's a reason is a nonlinear module that capture complex pattern, as you know here in the coding. So the type of a linear regression and then the decision tree is a supervised regressions. So the information I use a scale model. So overall, both of our model train and evaluate the same dataset split and supervised learning. For the evaluation metrics, I use MSC, like I say MSC and R2. So what MSE? MSE is a measure the average square difference between actual and the predicted value. So the less you have an error is a better accuracy. And then what R2 score is a proportion, a variant, a target to explain you. So the closer into the one proportion is a better. Uh, that's it. And confirmatories we want to know is a up and down prediction. So as you can see, the direction classification logic, if a close is a big row, open is a up one, and otherwise it's a down zero. Yes, basically. So last but not least is a result. Result you wash confusion matrix and then the plot predict and the actual ones. For the linear regression, you get uh, 0.93 accuracy, which is okay, and then the R2 score, the ones. So the accuracy is basically 79%, and the correlation is 51 out of 64. For the decision tree result, as you can see, the MSE error is a more error than the linear regression, which is 1.62. It's not better. So our two score is 0 0.99. So it's a different 0.01, which is closer to 1. So the accuracy up and down with a confusion metric is a 60%. So it's like less than uh, linear regression. And then the correct prediction is a 39 out of the 64. So it's not the accuracy compared to the linear regression is a more accuracy. So as you can see, it's important to us to know that a plot graph, which is a plot, is circle one is a green plot, is a more far than a line. Uh, that's it. And then you can watch my video to the next slide. To the next slide, which is I explain briefly about the coding. Thank you. I want to briefly explain about my coding, which is a crypto-ML, and then we use to forecast and predict the close target for the cryptocurrency. First of all, we need to I use the drive mount and just my dataset from dataset I got a Bitcoin, another cryptocurrency, and then we just put it in the drive, and then we mount in the drive. So just we uh, we run with the we want to dataset what you want in Bitcoin. So after that we feature which is we split the data, which is as open, high, low, and volume as you can see, and the Y is a close. And then for the split data, we use a train and test. Before you before you need to result, you need to train a data, and then we test the data. So test data 0.2, which is 2%, and then we get a random training 42. After that, I used two model two models, machine learning, which is a linear regression and a decision tree algorithm. So you can, as you can see, we need to know the output, right? So we have a result and then the model evaluation, which is a MSE and R2. So as you can see, the result here, a print, and then the result here, print, and then your result you can get from there. Yeah, and the coding. And then I use a plot. First of all, you need to know we need to install this library as a panda matplotlib and sklearn, and then you import a libraries. As example, we transplit and linear regression, decision tree, and so on lah. So this one is a visualize, which is a coefficient matrix, and then we this linear visualize lah, as you can see here. And then this additional is like if you want to Bitcoin, you type 1, and then you can also choose the another cryptocurrency. So just like this, and then we got a data set, and then we clearly select data set and number 1, which is a Polkadot, and then we get a result as a MSE. One more thing, MSE and R2 score, which is the less MSE error, which is the less, which is the better, and then R2 score 1.0 is excellent. So we closer is the closer one is much better than the far from the ones. So actually the regression is okay, it's alright. So we used to confusion metric, which is 64 box total, and then we got a 7 box 79% accuracy is okay. And then for the decision tree, 1.92 is a much error, so is a bad, and then 0.99 is a bad too. So we got here, and one more thing you need to look closer is a line. So they much far from this more accurate, and then this the point green point is a far, so much far. And then you need to know this confirmatory 64, and then the right about 49. Yeah, 49. So about 69%. So that's all. Thank you. I want to briefly